Hi, good day. My name is Erica Perez from TB. So in here, we will discuss the electrical machinery's generalization. First, we will discuss some things about the atom, particularly the structure of a copper atom. Copper atom has 29 protons and 34 neutrons in its nucleus, and has 29 electrons circling around the nucleus. And yung electrons in the outside shell, or makikita natin na yung kahuli-hulihang orbit ng ating atom ay tinatawag na valence electron. And as we can see here, the red arrow which represents the electrons and the blue dots are the protons. We will know the direction of electron in a copper atom when there is no induced voltage in the copper atom. The flow of direction are scattered everywhere or there are no permanent direction. And kapag naman nagkaroon ng induced voltage, the direction of electron will flow in one direction. And then, we will go on to the main topic, which is the generators and motors. Here are some difference between motors and generators. We have in terms of definition, their working principle, the current usage, and how the shaft is used. In motors, an electric motor is a machine that converts electrical energy to mechanical energy. Mostly, electric motors ito ay nag-ooperate through the interaction between the motor's magnetic field and the electric current to generate some force. While the generator is a machine that converts mechanical energy to electrical energy. So basically, baligtad lang sila, but the generators is for the transmission and distribution of electrical power for the automobiles, aircrafts, ships, and many more. The working principle naman of motors is based on the current carrying conductor that experience a force when it is kept in the magnetic field. In other terms, the force is applied kapag ang electric current is present sa magnetic field. And the working principle of generator is based on electromagnetic induction. Well, electromagnetic induction is kapag may motion between the coil and the magnetic field. Then an electric current or the EMF induced in a coil. In motor, the current is supplied to the armature windings, while in generator, the current is produced in the armature windings. The shaft of motor is driven by the magnetic force. In motor, the force is generated between the armature and the field, and while the shaft of generators is attached to the rotor and driven by mechanical force. Rotating electrical machines have two types, the AC and DC machines. AC machines is synchronous generators and motors, and the supply voltage is only given to stator and most supply is given to the rotor. Field poles are the rotor and the armature is the stator. While DC machines, the stator is used as a field and rotor as the armature. Take note that the rotor is about the rotating mechanism, while the stator is about the stationary mechanism. So for now, we will focus on the generators. Well, there are types of generators, the AC and DC generator, and it has differences. Well, both AC and DC generators use electromagnetic induction to generate electricity, but they have different process. In AC generators, alam naman natin na a generator is a machine that converts mechanical energy to electrical energy. But yung energy sa AC generator is created in the form of the alternating current na nagpa-flow in different direction. So, ayun nga, the coil when the current travels is normally stationary or fixed in one position and yung magnets ang gumagalaw dito. While in DC generators, yung DC generators naman ay mechanical energy to electrical energy in the form of direct current na nagpo-flow naman in one direction. Dito yung magnet naman ang umiikot sa coil, unlike sa AC kanina na ang umiikot ay yung armature. Dito umiikot yung coil kung saan yung coil is attached to the commutator that balances the charges to and from the generator. Kaya yung current ay hindi nag-iiba ng direction. Unlike nga sa AC kanina na wala siyang commutator na nagbabalance ng charges. Kaya kung saan-saan lang napupunta yung charges ng AC generators. Well, AC generator has two main parts, the armature and the field poles. Armature. It is the power generating component in generator where the voltage is produced and is made up of laminated steel core, consists of coils of copper, or called as are the armature windings. Ginagamit si armature to communicate between the two magnetic flux or the magnetic field to generate. Field poles. Field poles is the field poles. It is sets of pair of magnets or permanent magnets with south and north poles. It should be even in numbers and consist of laminated steel core of rectangular cross-section with coils of copper wire around it, which is called the field windings. Ginagamit si field poles to provide excitement sa isang electric machine and to spread out the flux in the air gap uniformly. And here are some more parts of an AC generators. It has slip rings, brush, and load. The slip rings, it is a hollow rings that are connected to the rotating terminals of the armature windings that provides electric contact with the brushes. It consists of parts, the S1 and the S2. Brush, it is connected to the slip rings that collects currents then supply it to the load. It also consists of the brush 1 and brush 2. And then there are the loads. It checks if there is a current flowing by swinging its needle, or it is called the galvanometer. Kailangan nagsuswing kasi yung needle sa galvanometer para malaman natin kung meron talagang current na nag-flow. Kapag hindi nag-swing yung ating galvanometer, ibig sabihin, nagkakaroon ng hindi maganda or hindi tama yung flow ng current. Then we have the working of AC generator. When the armature rotate between the pole of field magnets, yung magnetic flux na nakakonekta sa armature ay magkakaroon ng changes that result of the EMF or the electromagnetic field is induced in the armature. And that process will produce the current through the armature and the load or sa ating galvanometer and also through the slip rings and brush. Kasi doon siya dadaan sa brush and slip rings papunta sa galvanometer. But take note that the galvanometer needle should swing between negative and positive values para masabing meron talagang current na nag-flow sa galvanometer. Tulad nga ng sabi ko kanina sa definition ng load, kailangan gumalaw yung ating needle sa galvanometer from positive to negative para malaman natin kung meron talagang flow ng current. Kasi kapag hindi nag-swing yung needle ng ating galvanometer, ibig sabihin, ang ating AC generator ay hindi nag-function properly or nagkaroon ng mali sa naging rotation nito. And then we have the direction of induced current in an AC generators. Initially, we can see the armature ABCD is vertical with its arm up and CD down. Dito, ang direction ng magnetic field is from left to right. As the armature do a half rotation clockwise, or the arm AB moves down, and the arm CD moves up. According to the Fleming's right-hand rule, the current will flow in the direction of DCBA and flow directly to brush 1 to brush 2, then papuntang load or the galvanometer. Then during the next half rotation, the arm AB moves up and the arm CD moves down. And again, by Fleming's hand rule, the current will flow in the direction ABCD, that is from brush 1 to brush 2 through the galvanometer. Ibig sabihin lang nun, the induced current changes its direction in every half rotation of the armature. Then next, we have the DC generator. DC generator also have parts. We have the stator, split ring, brushes, and load. So as we can see, mas halos parang pareho lang sila ng AC generator ng parts. But in here in DC generator, we have the split rings. So first, we have the stator. It is the fixed part of a DC generator and it consists of permanent magnets, the north and south pole, which is placed around the rotor. And its main function is to provide magnetic field kung saan ang rotor or the armature is rotating. Then we have the split ring. It is the movable device used for reversing the polarity of the current and is made up of copper. The ring is divided in the middle into two parts and ginagamit ang slip ring to achieve a single direction of current. And then we have brushes. This is made up of a carbon rectangular block shape and its function is to collect currents from commutator segments. And then we have the load or the galvanometer. It is an analog electromechanical actuator that produces a rotary deflection of some type of pointers in response to electric current. And then we have the working principle of DC generator.
So
As
how
we can
does the
see, the
DC
current
generator
flow
work?
in one direction.
Firstly, we
Pero
don't want
paano
that
natin
current's direction
masisiguro
to
that the
change.
current
We want it to remain the
direction will
same at all
remain
times.
even if we
Let's say
rotate
in
the
this
armature,
direction.
kung
So,
i-require
how do
natin
we do that?
that this
Now,
brush is
what we
constantly
require
keep
is that these
changing
brushes
contact
constantly
between the
keep
wires
changing
in each
contacts
half
between
rotation.
these wires for each
So,
half
if the
of
current will
rotation.
flow in
To
clockwise,
this
the
wire.
brush must
So
be
current
connected to
flows
the
like
left
this
wire,
and comes
so the
out.
current will flow from left to right until it comes out in the right side of the wire.
But
But
when the
when the
coil
coil
rotates,
rotates,
you can
makikita
see that
natin
when the coil
that
comes
when
to
the
this
coil
position,
comes
the
to
direction of
horizontal
the current
position,
changes.
the direction of
If we
current
want to keep
changes
the current in the
because the
same
brush will have a
direction, we
contact
must
in the
this
right
brush
side of
to
the
be in
wire.
contact
And
with
if the
this
coil
wire.
do
And
another
again, when the
rotation,
coil comes to
the
this
left
position, again the
brush will
direction of
have
the
to
current
contact with the
changes.
left wire
And
or yung
again, we
unang
want
naging
this
contact
brush to
niya.
come in contact
So
with
if we
this
want the
wire.
current
Of rotation,
direction to
we
keep
must
the same
change contacts
direction,
with
we
rings.
will need to use split rings,
Split
just like
rings, as the name
its name.
suggests,
It is
is
a
a ring
ring
that is split in between,
that
giving
have a
two half
split
rings
in
with the same
between.
gap in between.
Giving two
Now
half
let's see
rings
how the
with the
split
same
rings
gap in
automatically
between the
change
split ring
contact for every
will
half a
provide the
rotation.
current flows in the same direction. And that
So
is how
right
the
off
DC
rotation, we must
generators
change
work.
contacts with
Where the current flows in one direction,
off
the
rotation, we must
arrangement
change
of
contacts
brushes
with
and split rings which help us to
off rotation,
automatically
we must
change
change
contacts is
contacts
called
with
commutators. Dito madidetermine ang direction of magnetic field and
determine all
force
this,
gamit ang
we must use Fleming's right-hand
Fleming's
rule.
right-hand
So
rule.
we will
As
explain
we
how
can see,
can
the
we use
rotation of
Fleming's
the coil
right-hand
is
rule. As you
clockwise,
can see, the
and the
rotation
force
of the
acting
coil is
in this part of the
clockwise,
coil
and the
AB,
force acting on
pushing
part of
the
the coil
part of the
AB
coil
pushing that part
upward.
of the coil upwards.
So
So to know the direction of the
induced
induced current, we
we
apply the
applied
Fleming's
Fleming's
right-hand
right-hand
rule.
rule.
How do we
The
do
thumb
that?
will show
We place our right hand
the
so that the
direction of
thumb points
force,
up,
and the
showing the
index
direction of the
finger
force.
pointing the
The index
direction
finger
of
or the
magnetic
finger
field
pointing in
from
direction of the
north to
magnetic
south
field from
poles,
north to south
and the
pole,
middle
and the
finger
middle
will
finger will
point in the
point in the
direction
direction
of
of the
induced
induced
current.
current,
To get the
which
induced
is in our
current in
case
the
from A
part
to
of
B.
C and D,
Similarly,
again,
to find
use
the
Fleming's
coil is
right-hand
clockwise,
rule so
part
the
of the coil
rotation of the
CD
coil
pushing
now
that
is
part of the coil
clockwise,
downwards.
and the force acting on
The
the
thumb
coil
points
CD
down,
pushing that
indicating
part
the
of the
direction
coil
of the
downwards,
force,
the thumb
indexed
points
finger
down,
or for the finger
indicating the
pointing in
force,
direction of the
and
magnetic
index
field
finger
from north
points
to
the
south,
direction
and
of
the middle
magnetic
finger will
field
point in
from
the
north to
direction of
south,
the induced
and lastly,
current,
the
which
middle
is in this
finger
case from C to
points the
D.
direction of the
So to
induced current.
conclude, the
So we
induced current
conclude that the
follows the path
induced current
ABCD
follows the
of the
part
coil.
A, B, C, and D
The induced
of the
current
coil, and
follows
the
the path
effects of the split rings
ABCD
is
of the
written as
coil.
commutators, and DC
The induced
generators
current
is to
follows the
ensure
path
that the induced
ABCD of the
EMF is
coil.
always in one direction. And then there are two types of motors, the AC and DC motors. AC motors, the energy comes from a magnetic field through the coils wrapped around the shaft and powered by alternating current. So AC motors are available in either single or three-phase configuration and consist of several parts including the stator and rotor, just like the generators. DC motors, the energy of it comes from batteries or another constant generated power source that offers constant voltage and power by direct current. While DC motors are available only in single-phase configuration and has several parts like bearing, shaft, and gearbox.